All right, we're going to go over lesson 11.4 today. We're talking about what's called the Pythagorean theorem. This is a really important principle for really all of math, but especially later on when we get into geometry, this is really important. And the Pythagorean theorem deals with triangles. So we have to remember a little bit about triangles. Remember, when we classify triangles, there are two ways to classify them, by their angles and by their sides. The Pythagorean theorem deals with classifying triangles by their angles. So there are three different types of triangles by their angles. You can have an acute triangle. That means that all of the angles of the triangle are acute, which means they are small. They're less than 90 degrees. So you can see all three of these angles are small. They are less than 90 degrees. So 90 degrees would be like an L. Less than that would be less than an L. This is an acute triangle. That means one of the angles are more than 90 degrees. So it's going to be a larger angle, more than 90 degrees. And then finally we have the right triangle. So the right triangle has one angle that is 90 degrees. We call that a right angle. And anytime you have a little box in one of the corners of the triangle, that means it is a right angle, which means you have a right triangle. So the theorem we're talking about today, the Pythagorean theorem, only works with the right triangle. So it's not for any triangle, it's only for right triangles. Now, what the theorem states is that when I have a right triangle, if I make a square off of each side of the triangle, then the two smaller squares areas will add up to the bigger square area. So for example, in this right triangle, if this side is 3, well, then that means all of these are going to be 3, and the area is going to be 3 times 3, which is 9. If this is 4, then if I make a square off the side, it's going to be 16. And if this is 5, the square off that side is 25. So if I add the two areas, 9 plus 16, I get 25. So written in an equation form, what this is a squared plus b squared equals c squared. What that means is the two smaller sides, we call those legs. The two smaller numbers are the legs, and they will always be next to the right angle. If I square both those numbers and I add them together, I will get the bigger side. We call that the hypotenuse squared. So the two smaller sides squared added together equals the biggest side squared, which is the hypotenuse. The hypotenuse will always be the longest side, and it will always be across from the right angle that we call the hypotenuse. So let's look at a couple problems to figure out how to do these type of equations. So let's start with this first one. Let's say I have a right triangle with legs that are 8 and 15. So remember, if I have the legs, that's this A and the B. It doesn't matter which one you use for A and which one you use for B. So I'm going to put the first leg as A. I'm going to square it. The second leg is B, and I'm going to square that, and that's going to equal my hypotenuse squared. So 8 squared is 64. 15 squared is 225. Remember, make sure you guys have memorized those. That will make this chapter a lot easier. And then that's going to equal c squared. So when I add these two together, 64 plus 225, I get 289. Now that is not my hypotenuse. That's not the hypotenuse. Your last step for these problems always is going to be to get the square root. This is c squared. I want c. So remember, I'm going to do the square root for both sides. Now remember, in the last lesson when we talked about doing the square root for both sides, we talked about how you always have to do plus or minus. Now, for this, we don't have to do plus or minus. And the reason why is because we're talking about a side of a triangle. You are never going to have a negative length. You can't have a negative length. So for this, you will always just use the positive, since we're talking about the length of a triangle. So I say, is there a square root of 289? Yes, there is. The square root of 289 is 17. So my answer is 17. If there's a label like inches or feet, make sure you write the label. In this case, I do not have a label. So my hypotenuse is 17. Let's take another example, 6 and 7. These are both legs. So again, I'm going to square 6. I'm going to square 7 to get my hypotenuse. So I have 36 plus 49. I add those two numbers together, and I get 85. But remember, 85 is not your answer. Your last step always, always, always has to be to square root your answer. So is there a square root of 85? No, I know there's a square root of 81. That's 9. 100 is 10. So there is no square root of 85. So guess what? Just leave your answer as the square root of 85. Just leave it in the square root, and that is your answer. It's an irrational number. Now, sometimes they are going to give you the hypotenuse and the leg. If they give you the two legs, that's the easiest because you just square them both and add them. And then when you get your answer, find the square root of your answer. So if they give you two legs, square both legs, add your answers together, and then find the square root of the answer. If there is no square root, leave it in the square root. But if they give you the hypotenuse and the leg, that's a little bit different. Remember, the hypotenuse is on this side. I have one leg, and I want my last leg. So what am I going to do? Well, let's write it out. I know my first leg is 7. I don't know my second leg, and I know my hypotenuse is 16. So 7 squared is 49 plus b squared equals 16 squared, which is 256. So remember how I solve these type of problems? I have the b squared here, so I want to isolate the thing that is being squared, so I'm going to subtract 49. When I subtract 49, I end up with 207. But remember, that's b squared, so I have to do the square root of both sides. Again, normally I would do plus minus, but since this is a length, I can't have a negative length, so all I need is the positive. Now, 207 does not have a square root, so my answer I leave inside the square root. It is the square root of 207. So that is my answer. So, if they give you two legs, square each leg, add, and then when you get your answer, do the square root. If it doesn't have a square root, leave it inside square root. If they give you the hypotenuse and the leg, you still square both, but then you're going to subtract the hypotenuse answer minus your leg. Then with that answer, you do the square root. Okay, so if they give the legs, square, add, square root. If they give you a hypotenuse in the leg, square both, subtract hypotenuse answer minus the leg squared to get your other leg squared, and then do the square root. Now, one last type of problem for this lesson is you can actually use the Pythagorean theorem in reverse. We call this the converse of the Pythagorean theorem. And what this says is, what we said with the Pythagorean theorem is if I have a right triangle, then I know that the two legs squared add up to equal the hypotenuse squared. What the converse says is if I don't know if something is a right triangle, but I have three sides, if I plug it into the formula and the two smaller numbers squared add to equal the bigger number squared, it is a right triangle. If they do not add together to equal the bigger number squared, it is not a right triangle. So I can figure out if something is a right triangle if I have three sides by plugging those into the Pythagorean theorem and checking. So I'm going to do that with two examples. Now, let me just erase my screen here. Alright, so I have a couple sets of numbers here. My first set is 12, 35, and 37. So, remember, if the Pythagorean theorem works, I'm going to take the two smaller numbers, square them both, and that should equal my bigger number squared. So I'm going to do 12 squared plus 35 squared equals 37 squared. And I'm going to check and see if that's a true statement. So I have 12 squared is 144. 35 squared is 1,225. 37 squared is 1,369. When I add 144 plus 1,225, I get 1,369. Do those equal each other? Yes, they do. So this is a right triangle. So I would write, yes, this is a right triangle. Because the Pythagorean theorem works, that proves that it is a right triangle. How about this set of numbers? Again, I'm going to take the two smaller numbers, square them, and that should equal my biggest number squared. 8 squared is 64, 12 squared is 144, and 14 squared is 196. When I do 144 plus 64, I get 208. Does 208 equal 196? No. So it didn't work. Since it doesn't work, that means it's not a right triangle. So if it's a right triangle, the two smaller things squared should equal the biggest one squared. If they don't, it's not a right triangle. That's the Pythagorean theorem.